Hi, good evening to our lecturer, Dr. Sharma Rao. Today, I will explain to you the part of our lab 3, which is the digital to analog converter. Uh, Introduce my lab members, which is me, Muhammad Arif Faisal Muhammad Azmi, and two partners, which is Muhammad Faisal. Okay, let me brief a little bit an overview for this lab session. So for this lab session is focus on the digital to analog converter, which is DAC, which is required and interfacing through a microprocessor to convert the digital to analog format by using the DAC 0800 device. The digital signal is processed from a binary states, then it is converted to analog signal. The aim of this lab session experiment is to understand the fundamental theory behind the DAC 0800 device, which is also consists of both unipolar and bipolar output voltage. Okay, next is the objective for this experiment, which this lab session is to understand the basic theory of the digital to analog converter. Second is to understand the operation theory and characteristic of DAC at 0800. And the third objective is to generate the unipolar and bipolar analog voltage by using DAC 0800. Okay, next slide is the circuit diagram for the unipolar voltage output, the overview of the circuit diagram for unipolar voltage output. Okay, next is the circuit diagram, also circuit diagram, but this is for the bipolar voltage output, which is more complicated than the previous circuit diagram. Okay, next slide is the equation to find the theoretical value for unipolar voltage output. To find current output, we use V reference over we calculate V reference over R1 times with D7 until D0 over 2, 4, 8, 16, 32, 128, and 25 as stated in the slide. And to find voltage output, we just multiply the I out that we gained earlier and with R3, which is the resistance 3. Okay, for the next slide is the theoretical equation that we calculate to obtain the current output, voltage output, and I bar output, which is the additional part for bipolar voltage output, the current bar output. The equation for current output, it is same as the previous equation for the unipolar voltage output, but the difference is to calculate the voltage output, which is we have to times with 2 I out R4 minus with IFS times R4. To find I bar out, we just subtract with IFS with what I out. Okay, this is the result that we obtained for the experiment 1, which is the DAC 0800 unipolar voltage output. The digital output is given in the table 1. It's given earlier in the table 1. And for the theoretical result, we obtain by using the equation that I mentioned earlier to find V out. For this lab, to find V out, we use the equation of V out is equal to I out R3, and this value is repeated from with the input that are given in the table 1. Okay, to measure the voltage output for experimental for practical value, the current meter is removed and J1 is short circuited, and the voltage digital meter is used. This step is repeated according to digital input that are given in the table 1. Okay, to find next is to find the I out. For the theoretical result, we just substitute the input into the equation earlier, which is the equation I out for the unipolar voltage output, and we obtain the result as stated in this slide, which is 0, 0.042 and more. Okay, for the measured result for I out, to find it, we need to open circuit the J1 first and connect the digital current meters to J1, and this step is repeated according to the digital input given in the table 1 also. Okay. Okay, this is the result for the experiment number 2, which is the experiment that used the bipolar voltage output circuit. Okay, to find the theoretical result, to get the theoretical result from the digital inputs, we just use the equation that we mentioned earlier in the previous slide, and we get shown in the slides. Okay, to find the voltage output for the measured result, we need to voltage output, first we need to J1 and J2 we need to short circuited, and J3 is open circuited, and the digital voltage meter is used to measure the output voltage. Okay, and the result is shown in the table by according to the digital inputs that are given in the table. Okay, to find the I out, we need to find the current out, we need to open circuited the J1 and J3, while J2 will be short circuited, and the digital current meter is connected to J2 to measure the output current, which is IO. Okay, and the data is data is according to the digital inputs that are given in the table also. To find the output, I bar output for the experiment 2, we need to open circuited the J1 and J3, and while the J1 will be short circuited, and the digital current meter is connected to J2 to measure the output currents I bar out. Okay, this is the result is obtained by substitute the input by substituting the input that are given in the table. Okay, and last but not least, to find I out plus I bar out, we need to sum up all the value of I out and the I bar out, and we obtain the value as stated in the slide. Okay, let's move to the discussion part. In the discussion part, there are 3 questions that we need to answer, which is the first question is asked for in experiment number 2, if the digital input signal is 0, 1, 1, 0, 1, 0, 1, 0, then what is the output voltage? Okay, the answer is for the practical value, if the digital input is 0, 1, 0, 0, 1, 1, 0, 1, 0, the output voltage is we get 0.81, while when we calculate the theoretical value using the equations, the output voltage is we get 0.86 voltage volts, 0.86 volts, and the difference between these two outputs is about 0.05. And I think this error happened due to the system error, because when we conducting the experiment, the voltage from the power supplies cannot supply exactly 5 volts. Okay, next is the question number 2, which is need us to explain the resolution and the step size of the DAC. Okay, the resolution in case of DAC is the smallest change in the analog voltage or current. It can detect for the output signals, and it's also known as step size. Okay, for an n bits DAC step size can be calculated using formula. Step size is equal to V reference over the 2 to the power of n minus 1, and in this experiment case, an 8-bit DAC is used, and the maximum output voltage that can produce is 5 volt. By using this formula, the step size that we gain is for this DAC is 19.607 millivolts. And for the resolution, it is often expressed as percentage, and the percent resolution for a bit DAC is 0.392%. Okay. Okay, last question for the discussion part, which is to discuss the application examples of DAC in the communication system and its functional operation. The applications that we obtain, that we get, which is the DAC is used in music player. First, DAC is used in music player. The function is to convert the digital signals into analog signals. Next application that we found, that it is used in TV remotes, mobile phones, where we need to communicate the digital to analog signal. Okay, and third application that we get, which is it is used in the audio amplifier, where the DAC will integrate into an entire output, entire audio cord that contains feature for signal processing. That's all for the discussion. Okay, last but not least, as the conclusions, basic theory of the digital to analog converter is implemented and exposed in this lab session by using the AC0800, and we managed to achieve all the lab's objective by the end of this lab session, and the result that we obtained from this lab session is likely different with the calculated value, but we already understand that the practical result is always differ from the theoretical result due to certain factor, either from the equipment itself or from the external factors. All these have been discussed in the discussion earlier in this discussion, but last but not least, the aim is to make the student, us as the students, understand and generate by ourselves for these two experiments for DAC using DAC0800 is successfully achieved. That's all from us. Thank you.